Hey guys, welcome back. Today we're going to be continuing our discussion on parallelograms. Firstly, I'd like to display this image right here and ask you to separate these characteristics based on the shapes we've already seen. I'm going to give you a couple minutes to do so. As I said before, look at these characteristics on the display and separate the characteristics based on the shapes we've already talked about, which would be a parallelogram and a rectangle. Go ahead and list out the characteristics, or separate the characteristics. They're mixed and matched in the display, so go ahead and just separate the characteristics to the shapes we've already talked about. As you may recall, parallelograms have these characteristics right here. Opposite sides are parallel. Remember, that's the symbol we use for parallel. Opposite angles and sides are congruent. That's the symbol we use for congruency. Opposite angles are supplementary. That means they add up to 90 degrees. And the diagonals bisect each other, which means the diagonals cut each other in half. Now, if you look at the characteristics for a rectangle, all angles are 90 degrees, and the diagonals are congruent. That means the diagonals are equal. Along with this, a rectangle is also a parallelogram, which means that a rectangle has these unique characteristics along with all of these characteristics. Remember, that's just a review from what we talked about last time. Now I'm going to display another image right here. And this image has all of the characteristics as the slide before, except a couple new ones. Distinguish which ones are new. Go ahead and do so. I'll give you a little bit of time to do that. Remember, this new image has, I want to say, 4 more characteristics. So it has the previous characteristics from the slide before, but now I've added 4 more characteristics. Go ahead and find those new characteristics. Okay, the additional angles that were added on the slide are these that I've written down here, which are all sides are congruent, diagonals are perpendicular, and diagonals bisect each other. Sorry, I mentioned there was 4 new characteristics. I meant to say 3. There's 3 new characteristics. And these characteristics describe one shape. Who wants to take a gander on what that shape is? If so, I'll draw it out. In a traditional classroom, I would have a student volunteer to draw it out. Since I'm the only one here, I'm going to be drawing it out myself. This, that are congruent. The diagonals are perpendicular, which means a 90-degree angle is formed right there. The diagonals bisect each other, which means they cut them in half. So this, for all angles. This right here, ladies and gentlemen, is a rhombus. It is a rhombus. Now let me ask you, is a rhombus a parallelogram? Is a rhombus a parallelogram? The answer is yes. A rhombus is indeed a parallelogram. Each opposite sides are parallel. Opposite angles are congruent. Opposite sides are congruent, it is indeed a parallelogram. And because it's a parallelogram, just like the rectangle, it holds all the characteristics of a parallelogram. Alright, so I kind of went briefly over it. The diagonals are perpendicular. That means that when they meet, they create a 90-degree angle, just as right here. My ideal perspective or plan for this lesson would be to put up a bunch of problems around the room, taped up to the wall of some sorts, and have students individually go to random problems and work on problems regarding the rhombus. However, since we cannot do that virtually, I'll just go over a couple problems, let's say 3, so that you get the idea of how to handle problems regarding the rhombus. So let's go with one problem right here. Again, assume all of the shapes I draw are of a rhombus. Okay, so say this is angle A, B, C, excuse me, C typically would be there, but I did it like that for whatever reason, and then E would be in the middle, and your side length AB is 13, and your side length BC, I'll write it over here, is 18. And we're looking for AE. If I could write. We're looking for AE. We're looking for BD. We're also looking for CE. So AE, BD, and CE and EB. Well, let's look. We know BD, right? Because all sides are congruent. So BD has to be 13. Okay. Since the diagonals bisect each other, it means they cut each diagonal in half. So CE is half of BC, right? So what's half of 18? Well, that's 9. So CE is 9. Now, don't assume that the diagonals are congruent. Remember, that it's a specific characteristic of a rectangle. We are not talking about a rectangle here. We're talking about a diagonal. So do not assume that side lengths ED and AE will also be 9. We cannot do that. However, there is still a way to find these side lengths. Okay? If you look here, this is a right angle, correct? And we know our side length AD is the side length we're trying to find. But we also know side length BE, which is congruent to side length CE, which is 9. And we know side length BD, which is 13. This forms a right triangle, y'all, where one leg is 9 and the hypotenuse is 13. So to find the side length ED, we just have to fill in the blank, okay? So we have it that 9 squared plus blank is equal to 13 squared. Okay? And this is going to represent our ED squared. So we'll go in our calculator and do 13 squared minus 9 squared, and that's 88. So we'll have 88 right there. What's the square root of 88? It's a decimal, and we'll leave it as 9.38 or 9.4. So ED is 9.4 along with AE. Don't freak out that it's a decimal number. It's okay. It happens like that. We have found the sine lengths of parallelograms. Please do not get it mixed up in a rhombus. Do not assume that the diagonals are congruent. That is a characteristic of a rectangle. Okay, so just because BC is 18, that doesn't mean AD is 18. As a matter of fact, we could find AD, which is be 9.4 times 2. Just multiply this by 2. And that is 18.76. So though they're similar, they're close, they're not exactly the same, okay? So be careful with that, alright? Let's try a different problem. Okay, here's the next problem, y'all. So here we have to find all of the missing angles, and they give us one angle, which is 24 degrees. Okay, again, this is a rhombus. So what do we know about a rhombus? We know that the diagonals bisect the opposite angle. So this diagonal here is splitting this entire angle up evenly in half. So if they're even, and if this is 24, what do you think F is? F is also 24. And since it's a parallelogram, opposite angles are congruent. So this whole angle here is 48 degrees. All of it right here is 48 degrees, which means this angle is also 48 degrees. But then again, it's also a rhombus. And the diagonal of a rhombus bisects the angle. Therefore, not only is F 24, but C and D is also 24. Alright, so we have found 3 of our missing angles, 3 more to go. So, how do we find the rest, right? Any ideas? How do we find the rest of the angles? How do we find A, B, and E? Well, what the interior angles of a quadrilateral, what does that add up to? It adds up to 360, right? But we found 2 of its angles, right? So we have 360 minus 48 minus 48 is 264. So this angle along with this entire angle should add up to 264. So let's divide that by 2 and say that this whole angle and this whole angle adds up to 132. And if we split that up again, since the diagonals are bisecting those angles, we have that this angle is 66, this angle is 66, and this angle is 66. So A, let's try that again, A is equal to B is equal to E is equal to 66. And if you don't believe that, the cat fell off of my marker, that's what that was. If you don't believe that, let's just do 66 times 4 is equal to 264, plus, in parentheses, we'll put 24 times 4, and that adds up to 360. So it's a different type of problem. You just have to keep in mind the characteristics of a rhombus. If it helps you, off to the side, write up the characteristics of a rhombus and also of a parallelogram, just to remind you what can and can't be done on specific shapes, okay? Let's try to do one more problem and then we'll move on. Okay, here's another problem. This is yet another rhombus, aka parallelogram, and we're given these two measurements. Let's find out what they are. FH is this diagonal right here, and that's 23. GJ, GJ is 11, which is this little segment of this diagonal right here. Now, we have to find IH, GI, JH, and JI. Okay? So first of all, let's discuss this. Looking at GI, knowing that this side length right here is 11. Let's try this. Try to make it a little darker here. Knowing GJ is 11, what can GI be? That's right, GI is 22. GI is 22. Since this is a parallelogram, we know diagonals bisect each other. We're good there. I'm sorry, excuse me. Yes, parallelogram. Characteristic of a parallelogram is diagonals bisect each other. We are good there. This and this is also 11, which adds up to 22. And by the same reasoning, since this is 11, we also found our JI. See, it's not as hard as it may look, okay? Now, let's look at JH. JH is half of whatever 23 is. So this is actually going to be a decimal of 11.5. Since 11.5 plus 11.5 is, of course, 23. So 11.5 here. Remember that this is a right angle because we're going to need it to find our IH. This forms a right triangle with two legs of 11 and 11.5. Off to the side here, you'll do 11 squared plus 11.5 squared is equal to something, right? We'll take our calculator right here. Make sure you can see that. It's 11 squared plus 11.5 squared is equal to 253.25, and of course that's not our answer. We have to take the square root. Again, it's going to be another decimal value. Don't worry about that. It's 15.91. There you go. 15.91. We have found the side length that's requested. Again, don't be intimidated by the amount of measurements it's asking for. A lot of the times, to get you started, the measurements they give you is going to give you some type of measurements here. For instance, they gave us JH. We know diagonals bisect each other, which means they're cut in half equally. So if this is JH, that means our IJ is also equivalent to GJ, and that's 11, which is right here. We double it to get GI. The hardest part would be coming up with this right triangle, but again, remember this right angle is always going to be there since the diagonals are perpendicular, specific to a rhombus, okay? Now, as you finish up writing that, I'm going to present you the image with all the characteristics. All the characteristics right here, right? This slide holds all the characteristics we've been talking about as far as parallelograms, rectangles, and rhombus. There exists a shape that has all of the characteristics listed on this slide. Go ahead and take a few minutes and try to draw this shape that has all of these characteristics. The shape that holds all of those characteristics is none other than the square. And if I was a good drawer, I would draw the square accurately, but I'm not, so that's what y'all get. The square. The square holds all of those characteristics, okay? So what we're about to do now, just as we did before, we're going to do a couple of example problems involving the square and how to handle all of its properties, okay? So let me label this real quick now that I have it drawn. With that E. Alright, so we have AB is 15. And we are looking for, now don't be intimidated by how many measurements we're looking for. You will see that they're not so bad after a couple of examples. Okay, so we have quite a bit of measurements to find, right? Given the problem, let's just do equal signs, and we're only given one measurement, which is AB, which is 15. Don't worry, y'all. Don't worry, okay? Because you know more about the square than you actually think. Don't let all the characteristics about a square intimidate you on how to tackle this problem, okay? Let's just handle it one at a time. For example, DC is obviously 15, right? Because all of its side lengths are congruent. Just like the rhombus holds, the square holds all of those characteristics. Okay? Now, since this is 15 and similar to the rectangle, this has to be 90 degrees, right? We have 15 and 15, and we can find that hypotenuse if we look at the right triangle that is right here. I'm looking at this section of the square, and I just enlarged it. We'll do 15 squared times 15 squared. And that is 450. We'll take the square root of that, and it'll be 21.21, which is AC. And now we found our AC value. And since we found our AC value, we have found our BD value, since diagonals are congruent. And our EB value is half of our, our EB value is half of our BD value, which is, just divide that by 2 right here, and we'll say 10.6. Now we found all the side measurements. Now we have to find angles. We have to find the measure of angle DCB, which is right here. Sorry, excuse me about that, which is right here, DCB. And what do you know? It's a corner angle, which means it has to be 90. Now we have to find the measure of angle DAC, which is going to be DAC. This diagonal bisects the angle. What's half of 90? 45. DEC, similar to the rhombus, the diagonals are perpendicular. What is this again? It's another 90-degree angle. Now DCA, again the diagonals bisect the angles, so this is again 45 degrees. So a lot of it is just what you would think. The squares arguably are probably the easier shapes to deal with. Though we had a lot of measurements to find, it didn't take us very long, okay? That's the important part I want you to remember. So don't get frustrated or intimidated by the amount of characteristics a square has or the amount of measurements you have to find using a square. They are sincerely doable, and we'll do a couple more examples just in case you're still a little iffy on it. Okay, just as before, we have another square, another measurement that they give us, and a whole list of measurements that they want us to find. We have to find side length DC, located right here, CB, located right there, measure of angle BEA, which is that right there, side length AC, which is that diagonal right there, measure of angle EAB, which is right here, BCE, measure of angle BCE, which is right there, measure of angle DEA, which is this angle right here, and last but not least, measure of angle ABC, which is ABC. And of course they give us the diagonal 18, the horizontal diagonal 18th. Okay, how can we solve this? So, we know that diagonals are congruent, so we could say AC is also 18, the other diagonal. Okay, and diagonals bisect each other, so we know that this angle right here is 9, along with this angle right here is 9. Okay, we'll use that later. We will use that later. Measure of angle BEA, which is right here, BEA, because diagonals are perpendicular, we know that diagonals create a 90-degree angle. So the measurement of angle BEA is 90 degrees. Now, if this is 90 degrees, what does this angle have to be? It has to be 90 degrees also. And if this is 90 degrees, then what does this angle have to be? It's also 90 degrees. Now, do you see what I've made here? I've made a right triangle where the legs are both 9, respectively. Right here, I'm looking at this section right here. I just drew it again. We're going to use that, just as we did before. 9 squared plus 9 squared is equal to 162. Take the square root of that. And that is 12.7, let's round up to 3. 12.73, and that's your angle DC, which is right here. Of course, that's going to equal the same thing with CB, since it's a square and all side lengths are equal to one another. Let's look at measure of angle EAB. We're running down the list, as you can see. Now it's measure of angle EAB, which can be found right here. As I mentioned before, just like a rhombus, the diagonals bisect the angles. So if this is going to be 90 because it's a square, then if this diagonal is bisecting, what does bisecting mean again? It means cut in half. So if this diagonal is cutting in half this 90-degree angle, the measure of angle EAB has to be 45. BCE also has to be 45 for the same reasoning. Angle DEA, discussed earlier, is 90 degrees, since DEA is right next to two 90-degree angles. And of course, last but not least, the measure of angle ABC. ABC creates another 90-degree angle. So they're not tough, they're not intimidating, you just have to work through it step by step. Alright guys? You have more square problems right here, not a lot. Not a lot. And you also have a homework problem, 7 questions, also not a lot, and I'll display right here. Thank you for taking your time to listen today. I hope the first-person camera wasn't too distracting. I try to make it as easy of a transition as I could. I hope this was helpful to you. We have just discussed square